Hello everyone, Mr. Kaczynski down here in the corner. Got the solutions to 3.4 practice your skills coming at you. Let's do it. First one, we've got some recursive rules and some equations. We're gonna match them up. All right, the first thing I would probably do is look at y-intercepts or starting amounts. I see that equations 1 and 4 both have y-intercepts of 4. So let's find the recursive rules that have those starting spots, and that would be recursive rules B and D. All right, so then we have to go to a tiebreaker here, and I'm looking at equation 1 that has a slope of -3, which is indicated by this rule right here in equation D. So now we've got an answer here. D is equation I, or maybe equation I is choice D, and then 4, or B, is equation 4, or maybe we'd say 4 is recursive rule B. Okay, jump into the next ones. All right, well, this one's got a y-intercept of 3, and this one's got a y-intercept of 3, so I think that's gonna do everything for us. It also shows a slope of 4, and there's our slope of 4. So I think we can answer this. A is equation 2, or maybe equation 2 is recursive rule A. And that would leave 3 with the y-intercept of -3 and the slope of -4 as equation C, or maybe C is a recursive rule C. Or maybe C is equation 3. All right, I think we got it. Let's go D, A, C, B. Write an equation in intercept form that will provide the data values, jump number, and position for any of the number of jumps for Rabbit Percy. Use X for the input variable and Y for the output. Okay, so basically we're going to do Y equals, let's do his starting value, which is right there. And that is what, 10, 9, 8, 7. So 7. He's jumping forward, progressing spots. So the thing we need to figure out is how far forward. Okay, how many locations is that? And it looks like, oops, repetitively, Percy is jumping 1, 2, 3, 4, 5. So adding 5. 1, 2, 3, 4, 5. Yeah. Adding 5 every time. So plus 5 times X. And that would be our equation. Y equals 7 plus 5X. All right, so kind of need a graphing calculator to do number 3 properly in the way we're being told to do it. It says you can use the equation D equals 4.7 plus 2.8t to model a walk in which the distance from motion sensor D is measured in feet and time. So just like we did in the investigation. T is measured in seconds, D is measured in feet. Graph the equation and use the trace function to approximate distances. All right, here we go. Let's go to Y equals on our graphing calculator. In Y equals, I'm going to type my equation, 4.7 plus 2.8x. You can use Desmos.com. It's got a good graphing calculator that works really well for stuff like this. You should try it out and play around with it. But I'm going to use my graphing calculator. All right. So for 12 seconds, that's our input. Let's graph this first of all. You know what? Let's change the window on this too. Let's do a 0 to 6 second time interval. Those are our X values. So I hit window and I change my minimum and maximum for X. And let's go 0 to 6 for our, that might not be long enough actually, but we'll try it 0 to 6 for our distance from the sensor. Yeah, that's not very good because we're starting at 4.7 and going 2.8 from there. So let's go, if we go like 15, see what that looks like. Yeah, it looks a little bit better. All right, so we're going to use the trace function. It's right here, 12 seconds. So you can actually type 12 and hit enter, but it goes off the screen. So let's change my window again. Let's go to like 30. That'll be safe. I don't know any motion sensors that can read that far, but there we go. Got everything we need now. All right, let's go trace. We're going to go 12, enter. Why? Oh, because I didn't go far enough out on this. Okay. Let's go. We have to go out to at least 12 seconds. So let's go to 15 seconds. Sorry. Seeing the sausage being made here. All right, trace 12, enter. We finally got it. 38.3, which doesn't even appear on the screen. So let's change our window again. Let's go to like 50. All right, now we got a good graph. Let's go trace 12, enter. There we go, 38.3, finally. So 38.3, and that's meters. And 7.4 gives us 25.42 meters. All right, what is the real world meaning of 4.7? That the walker started 4.7 meters from the sensor. Let's put that in green because I've been using green to indicate starting location. What's the real world meaning of the 2.8? And that is the walker is going at a rate of 2.8 meters per second away from the sensor. Should probably indicate away from the sensor because it's a positive value. Let's do that in red, because I've been showing rates in red. All right, next up, undo the order of operations to find the value of x in each equation. So we're going to fill out this whole table here. All right, so first of all, let's figure out what's being done to x based on this equation. We're picking x, and then we're going to subtract 5.2. Then we're going to multiply by 3, and then we're going to add 7.8. To undo those things, we would add 5.2, divide by 3, and subtract 7.8. All right, the result ends up being 14. You can see that right there. So let's start at 14. Enter. All right, we're going to subtract 7.8. And that gives us 6.2. As far as our equation goes, that's going to give us 3 times x minus 5.2 equals 6.2. So it gets rid of that 7.8 when we subtract the 7.8 from both sides. Next up, we're going to divide by 3. All right, that gives us 2.6 repeating. All right, so in our equation, that would give us x minus 5.2 equals 2.6 repeating. Just gets rid of that multiplying by 3. And then lastly, we're going to add 5.2. All right, and that gives us our answer. Not a very pretty answer, 7.26 repeating. And our equation would just be x equals 7.26 repeating. Let's check that answer by doing these operations to it. Let's subtract 5.2, multiply by 3, and add 7.8. There it is, 14. All right, let's do it again. What's being done to x here? We're subtracting 8 from it. Then we're going to divide it by 4. Then we're going to multiply by 3.5. To undo those things, we're going to add 8, multiply by 4, and divide by 3.5. The final result we know is 2.8. All right, let's clear this off. Start with our 2.8 and work up, undoing operations. So divide by 3.5. That gives us 0.8 for our equation. I'm going to do it over here to the right. It would be x minus 8 over 4 equals 0.8. All right, next we're going to multiply by 4. That gives us 3.2. All right, so that would be x minus 8 equals 3.2. And then lastly, we're going to add 8, which gives us 11.2. And our equation would just be x equals 11.2. So let's check that math by subtracting 8, dividing by 4, and multiplying by 3.5, and we should get 2.8. We do. All right, last one. This equation gives the distance a sports car is from Flint after X minutes. How far is the sports car from Flint after 25 minutes? There's a few ways we could do this. We could do it graphically. We could undo the table, or we could use this equation method here. I think I'll just plug it in. So I'm going to do y equals 35 plus 0.8 times 25. So 0.8 times 25, that is 20 miles, meaning the car has traveled 20 miles since it left. But when you add that 35-mile head start that it already had, the car is 55 miles away from Flint after 25 minutes. So 55 miles. And then we'll do how long will it take until the sports car is 75 miles from Flint. So we're going to do 75, that's our output now, equals 35 plus 0.8x. So to undo this, we would take that 75 and we would subtract 35 from it, which gives us 40. So 40 equals 0.8x. And then to undo that, multiplying by 0.8, we would divide by 0.8, which gives us 50. So 50 minutes equals x. Let's take a quick second and let's graph this. Let's go y equals 35 plus 0.8x. Let's set our window from 0 to, let's go up to an hour, so 60 minutes. And then let's go for a distance. What was our max distance here? We started at 35, but we'll start at 0. And we got up to 75 miles away, so let's just go 100 miles away. There's a graph of the situation. We can use the trace function on the calculator and figure out, okay, 25 minutes, that's 55 miles. And then we can just use the buttons to go to, okay, when is it 75 miles away? And I can just press to the right until I get to 75. I'm at 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. That's really close to 75 right in there. So remember, we got 50, type 50. There it is, 75 miles away. All right, that's it. I hope this helps. Good luck and see you soon.